Okay, so the question is, how do you know that this term is squared? And so the answer to that is by the behavior at the asymptote. So if you notice at -3 here, this side of the graph is going to positive infinity, and this side is going to negative infinity. And so that's the behavior we would expect when something is 2 in odd power, so for our purposes, either to the first or to the second. When the graph is going the same direction, this, as it approaches 4, goes to infinity, as it does from this side as well. One side's going up, but so is the other. It's not going in opposite directions. That's the behavior we'd expect for when it's squared. And that's because if we look at our parent functions, when we have 1 over x, one of the side goes down, one side goes up at the asymptote. When we have 1 over x squared, notice both sides go off to infinity together. My joke about this is x to the first, this is like they got divorced. So one side's going this way and the other side's going this way, never to see each other again. And squared is like they got married and they're going off to infinity together. But so if you see a graph, I think I have an example down here somewhere. Yeah. So if we look at this graph right here, looking at the behavior of these two, how they're going together, that term, whatever that point was, I think it's 1, that would be a squared. Versus this side, where this side goes to negative infinity and this side goes to positive infinity, that side would be multiplicity 1 or to the first.